Today I'm setting up the new Creator Pro2. So I didn't even know this existed until 2 weeks ago. Well, my team ordered it and now we're gonna set it up, and if it's anything like the Creator Pro original, then it's gonna be great. And the cool feature is it has the twin extruders with independent control. And that's amazing depending on the software. If the software does everything that we want it to do, this is gonna be great. So let's set it up. I'm heating up the bed just to test that out. We're plugged into 240 volts and the extruder kits come nearly assembled. The assembly on these machines is really easy. I think the Flashforge machine is quite underrated in the community. And what people don't realize is this is maybe one of the low-end machines that has a steel frame. Okay, it's very rigid, and it has the enclosure that gives you the ability to print ABS right out of the box, and it just works. I've never had one of these actually wear out on anything except for like a nozzle, right? But nothing that's intended to be long-lasting wore out on my original Creator. These units are more compact than the Creator. They seem like I really like this slim fan because I would actually remove the fan from mine. I only printed in ABS. I was trying to do production style where we keep as few variables as we can, but so I would remove, actually on my Creator, I would remove one of these to reduce the sprung mass or the moving mass. And now they really cleaned them up. I love this slim fan. It goes into that injection molded nozzle, and that's gonna come down here. So, I mean, you only activate it if you want it, but we probably won't most of the time. I'm gonna try to jump right into ABS because I had this ender for the last few months. I had to print only PET-G because it just can't do ABS. It's gonna warp without having an enclosure. This one, I just set it on here and now it's not wiggling, and I'm gonna put the screws in from the bottom, but this one is wiggling, so I gotta figure out what's interfering. Noticing this cast aluminum base, that's pretty cool. But what feature is sitting here and interfering with me? I got no debris. These 4 threaded pegs are gonna sit right there. Oh, okay, maybe it's just the angle. Now it's not wiggling. Time to find the hardware. Extruder mounting screws. I mean, I don't think I'm gonna have to open up any kind of manual for this. I'm just kidding. I am gonna open up the quick sort guide because it's right here. I need to know what those little aluminum stamped pieces are for. Warnings, hot, moving parts, download this, download the newest user's guide, which traditionally I've not seen any good user's guide from. It's just exactly the same as what's on paper. Quality of the user's guide is not very good from Flashforge. Open box, do the stuff that I already did. We're just taking things out of foam. Hold both sides, slowly lift, already did that. Got all the foam out. About the Creator Pro, we got features, leveling nuts, okay, bolt hole over the platform, make the dual extruder, 2.5 Allen wrench, 4 M3 bolts, adjust the extruder location to align the bolt holes, secure the extruder. So it's just this. Okay. Not a very good camera angle. I'm not a cinematographer exactly, so That's what I'm gonna do. Gosh. I'm an engineer, not a cameraman. So this is the M3. Gotta find the wrench. It's the bag of wrenches. So M3 goes with probably this 2mm. Nope. I already have so many sets of these. If I could just trade in all these silver ones for one set that's color coded, like geez. Well, infinitely more helpful that would be if they had color on them. And I've painted these before. I've sat there with fingernail polish and painted these. It works, but it's time consuming. That's why God made interns. Don't laugh, it's important. It's an important job. Okay, I'm gonna just cut the camera while I put these screws in down here. So, unless you worked in manufacturing, people probably don't realize how many thoughts went into preparing the instructions, even though they're minimal, and the fact that they took engineering actions to eliminate instructions. What I mean by that is, like, who's to say these are on the right side, the right and the left? Well, actually, it's a poke-yoke. In Japanese, that means I've got a fail-safe where this one only fits with a fan over here, so I can't accidentally put it on the wrong side, screw it all together, start a print, and find out that I did it wrong. And I just think that's some of the brilliance of this Flashforge brand that nobody really gives them credit for. I mean, until you've used 3D printers for a while, you will not say, oh, Flashforge is the best, or Flashforge is worth the extra money we paid because it costs 3 times more than Ender. And if you're in Asia, go figure. In China, these things are made in China, okay? I think it's a USA company, and shipping to Malaysia costs like no less than, you're gonna pay an extra $200 at least. I guess it's in import fees, it's not really about shipping because they ship them in bulk to a couple of vendors, but it was actually quite hard to find a vendor in Malaysia. Like, this is just a seller on Shopee, which is like a Malaysian version of eBay kind of thing. And it's, well, I'm gonna have to see if we can drive this thing up. Tools, manual move, Z. This touchscreen wasn't on the last Creator. Flashforge made the Dreamer, which had a little bit of user-friendly functions like this touchscreen. The Dreamer costs a little bit more, and then they made the Creator, which has a steel frame instead of plastic. And the Creator is just a little more robust, but less beautified. It also, I don't think the Creator has the Wi-Fi. I don't think this one has Wi-Fi either, and I don't like it. I don't like to print online. I like to print using a SD card. Everything's about reliability. I don't care for bells and whistles. As I plug in my second of 2 independent dual extruders. Yeah, I'm really hoping the software is gonna eventually let me print 2 parts simultaneously. That would be awesome. That's gonna make this all worth the money. Okay, you're looking at these pages the very first time that I'm looking at them. So you can think my thoughts if you want to. Bolt holes secured, all these are finished. Backside, we're not gonna look at that at this moment. Okay, nice description on the best way to feed. It's all top cover. I'm just looking for, anti-oozing plate. You know why that matters? If you claim to have dual independent extruders, then you've got to be able to keep them both heated and allow one of them to drip, because that's just what extruders do. Then rapidly clean it off before you start printing on the alternate extruder. So fix the anti-oozing plate by 2 screws on, 1 for each. Okay, I think I can find that. So here's what's going on. It goes in the back there. So let me get this. I think I see how this works. So the inactive extruder is going to travel over here when it's not busy. And either this is going to be acting as a cap that covers the extruder, puts some back pressure on it, or it's going to be a scraping plate. Anti-ooze sounds more like a cap than a scraping plate. Oh, there's probably a better way to do this. But the better way is without a camera. That's when I don't let the camera get in the way of your business. Title of your tape. Well, I don't think I'm going to pick up that line of jokes. That's reserved for Jake Peralta. Shit, man. Okay, I'm turning it off. I'm gonna do this on my own. There it is. It helps to push the extruder to the opposite side. Also helps to keep the top one loose so that the aluminum hangs down instead of trying to interfere with your... See, these are getting... I feel snugness before I contacted the aluminum, so that's interesting. Everything you do with these Allen wrenches and these M3, M2 small screws, you have to realize that the reason that the Allen wrench has the small end is to limit the torque you can put on it. When you max out your finger pressure on this thing until it starts to hurt your finger, that's when it's just enough torque for the screw. In cases like this, some special cases you want to use the long end, but really you should think twice if you have to do that. Okay, so this thing comes over. Yeah, you see that compliance? It's the aluminum's always pushing out. Brilliant. Simple things are brilliant things. Looks like I chose the right side. Let me try to put the right side, bottom screw in first on this one. Okay, so take note, these motor assemblies are not symmetric because this aluminum angles back into the printer. The other aluminum plate angles forwards towards out of the printer. And then I'm noticing the motors themselves are switched. Like this one's further away from me. This one over here is closer to me. All right, this camera's in the way. Let's test it out. And we have contact. Doop, doop. Beautiful. Now I called this solution brilliant, but obviously I haven't even seen if it works yet. All I'm saying is that if a company like Flashforge is already selling thousands of units a month, implements this simple solution, they must have tested a lot. And there's no amount of finite element analysis that could tell you, or fluid dynamics simulations that could tell you without a test if this pressure is sufficient. All the deviations on these nozzles, with and without use, if you could just stop the flow like this. Okay, so that took real testing. You know, the innards of these brass nozzles are not trivial. I was at a conference the other day, last year, and I heard a talk from a professor from Madison, Wisconsin. And inside the nozzle, you have this, you have a flat the fluid flowing through here, and by the way, it's got a phase change, and so obviously it's not a fluid the whole time. Up here it might be solid, and then it's starting to become a fluid. And the normal typical low cost inside is like this, okay? And so very against my intuition, he's telling me that if this is flat, when you consider the heat transfer and the fluid flow and the pressure gradient throughout this thing, that this has a better performance. Of course, that's not how we're making them, because they're low cost. They're made by the thousands, and we use normal twist drills, which a normal twist drill has this kind of angle. So this is what we get from the store, and this is going to be better performance, and that's based on a very, very detailed study from one researcher doing many trials, and it would have to still be validated further, but it's just to show like the nuances inside this nozzle are there's a lot going on, and there's a lot of room for 3D printing to be improved. So yeah, no, there's no way I could say, well, sure, if you just set something here and whatever the deviations are, it'll stop the flow from dripping. Back to the book. Okay. We were, I'm gonna put it in the guide. Top cover. Oh, I think I skipped a step. To load the extruder, manually insert the filament into the feeding well. I mean, in this picture it's already in. Assembling the extruder, sticking the spools on. Orient the spool. Pay attention to the extend the guide tube to the inside of the spool to prevent the filament from being entangled. Yeah, that's true. That happens, by the way. Install the top cover. Here's a clue for everyone. If they took the time to put it in the manual, this manual could be this thick, okay? But it's not. If they make a comment in the manual, it is probably worth reading. The only time that you can negate that fact is if that manual was made 10 years ago for 10 different models and 4 different variations in 6 different countries. Okay, then maybe it's just got a bunch of information that you'd have to filter through. But this is a thin manual. I'm seeing nothing except for that I just have to jam it in. So I'm gonna pull this thing out. Yeah, okay, I can see that the diameter gets smaller, and there's no like clip, there's no clasp, so I'm not gonna expect to feel any. Yeah, I can feel it bottom out now. That's about 5 millimeters, no more than 5 or 6 millimeters, seriously. That's how you know it's in, and supposedly that will be secure. I gotta find the other tube though, it's in the box. Okay, back on this side, I mean, you can't see it the best, but I'm sliding this down. Instead of snapping them in, it takes a lot of finger pressure. I'm sliding them in from above. And you might have to just rotate it until it works its way. And then all the way down to this bottom. So I'm twisting and pushing. So this one I should have done this end first. Okay, and then it has to meet, so touch that little spot here, and that's what keeps everything steady. Also less noisy because we don't like the rattles. Okay, shove it in the top. So this is what the lid looks like. And again, the performance is a lot better than it looks. The rattling, just the rattling solutions alone, I mean, I don't have problems with that, and that's impressive. It's thick. It doesn't scratch that easily. You just don't put metal on it. And then when you put it on, feed those in, you slide it towards the front, so the little tabs slide under the nest. This one might have a burr from manufacturing. Okay, so there it is. This is an injection molded polycarbonate top. Okay, keeps the heat in, keeps the noise in, and keeps everything pretty. Let's see if we can print. Okay, there's an after sales service card. Won't get into that. There's an extra bed plate thing, and there's this leveling card, which is just like paper but more waterproof and stuff. Maybe the thickness is different. I haven't checked. Let's create some added value in this video. Let's measure that. Why not find out? Okay, so we have our origin count, and it's zeroed, and our paper is 20, sorry, 0.2 millimeters, 0.22, 0.22, 0.22, okay, it's 0.22 millimeters. These things are the clips for spools. I don't remember if this diameter is compatible for me, because I buy whatever spools I want. In this case, okay, that's crazy. I got the Flashforge. I've never bought their filament before, but now I did. We got blue. I've not used blue this year yet, so let's jump into the blue. 1.75 ABS filament, 1 kg blue. And in Malaysia, or here in an office like this, where very poorly controlled conditions, ABS is so important because it doesn't absorb the moisture. It doesn't degrade nearly as fast as PLA, ABS, I'm sorry, PLA or PETG or I don't know. It's been more reliable for me over time, and that's a quality control issue for me. I don't want to come back and change my print settings every time another fraction of a gram of water gets absorbed by my spool. That's just nuts. It's crazy. So since it's Flashforge, by the way, so here's how this goes. There's little tabs here. Just kind of have to finagle it. I'm going to remove this again because I have to tilt this against the back. And then here, finagle. It doesn't want to be finagled very much. The sound is unpleasant, but the result, oh my gosh. Okay. The result is this thing's pretty close. That's awesome because I can keep this closer to the wall. And I'm going to clip this end before I begin. Can I let go of it? Ooh. Flashforge doesn't provide you with is this thing that came with the ender. See, the Ender knows its customers. It knows that the customers don't have tools already necessarily. So it's a beginner entry-level device, and so they include that, what do you call them? Flush cutters. And flush cutters are excellent for filament. I'm making a mess here, and again, I'm blaming the camera because I know how to do this without making a mess. You gotta keep tension, but I'm standing over a tripod. This is starting to get silly. Turn it off. Okay, that spool is at risk of turning into a hairball, so I'm gonna try to load it now and get some tension, get it fed through smoothly. Filament, right, extruder load. I'm doing this because I know the temperature is high enough. And it says 230. That's lower than I print for ABS, but it's going to be okay for loading. I don't even know what it's going to do now. Hopefully all the end stops and the wires are connected. This is a haphazard going at it. Left side travel, right side travel. And heating. Well, I won't make you watch the heating. So this is the problem when you have a fresh spool. The filament is so close to the edge of the spool that it doesn't get guided very well. And if you don't keep a little friction on the rotation of this, then this filament can backfeed, and then it can just come loose, get caught around that thing, and that's a little bit of an ugly situation. So I have to monitor this when we start feeding. 200. Nothing's smoking. Nothing's humming or buzzing. That's good. The fan is on. This one's not. So that means I'm controlling the correct side. Oh, here we go. When it comes within, I think, 2 degrees, it believes it's ready. 3 degrees. Load begins. Push filament vertically, blah, blah, blah. Okay, I'm gonna go to the back and feed this. I need a better technique. Just got nervous. I was doing it just fine. I was pushing a little bit of pressure from the back. You couldn't see me. And then, and that is going smooth. Very nice. Good stuff. Okay, so I'm just gonna press done. And I'm gonna see if I can just make a print with the right side only. I mean, I don't assume it has any samples, but print. Okay, it needs a card first. And, I mean, since we're all here, this is the card that comes with special fittings for 3D printers. I don't know what a fitting is in the context of a 3D printer, but okay, this comes over here, and get ready. I'm probably going to print benchy instead of whatever's on here. I'm familiar enough with benchy that if I print one, then I'll learn something that I can compare to my experience. Flash print. Test files. Benchy, oh awesome, but it's in PLA. Mirror. Okay, well I'm not gonna do that. I'll make my own benchy, see what happens. Right now I'm going to preheat to keep the extruder off, platform on. 100 degrees is fine. And I'll just leave it like that so it prints faster when I'm ready. Time to go to the computer. All right, this guy goes in. And platform is heated, print from SD card. 3D benchy. I mean, this doesn't look right because it doesn't have the preview of the image, but let's just see what happens. Oh, I'll probably have to clear this. Print. Canceling build. Huh. Okay, I guess it doesn't like that kind of file. Print files do not match. Alright, fine. Okay, for starting things, let's just install Flash Print. I don't mind having it. Sometimes it's useful, but if possible, I'm going to standardize. I'm going to make everything happen through Simplify 3D. Okay, maybe I need to unzip first. You never know. Extract all. Okay. An instance is already running. Oh, okay. United States, okay. Welcome to the wizard. I accept. Seems okay. Install. May take several minutes. Allow it. Yes. Everything pops up on the left side window. Device driver installation, okay. Whoa. Sure. Launch. Finish. New version. No, not right now. Oh shoot. Flashforge Creator Pro 2, okay. Alright. Upgrade later, upgrade later. Alright, load. Let's just see if we open this. Whoa. I'll have to try that out later. Okay, that's what it's going to look like. It's supposed to take 53 minutes. I'm going to grab this thing and try again. So that goes in. And print. There it is. See the little icon? Do it. Well, I don't know if I clicked right extruder. And try it. Right extruder is the one heating up, so I think we're good. While that's heating up, let's check if we just totally forgot any pieces. And these look like maintenance. And I'm gonna do the grease. I'm gonna grease all the sliders, not the plastic parts, just metal to metal parts. And everything else is just maintenance. Okay. 165 out of 240. Right now is about when we would get oozing. Let's see the tripod up close. $220, $227. Pan is spinning away. It's kind of weird how this is a little bit blurry. It's in focus, but oh shoot, I didn't level anything. Okay, actually we gotta level this stuff, obviously. Tools, level, with instructions. So I started to print the benchy, but yeah, obviously. I'm gonna blame this on the fact that I'm trying to make a video instead of focusing on the work. So we're gonna use the little 0.22 millimeter sheet of paper to do the leveling. And the process is and these are already tight, so now tap next. Adjust the front. Okay. Okay, now I can just start to feel friction. All right. Next. Tighten. And that one was too tight. I left a little mark on my paper too. Just a little bit. Okay. Next. I just press an X on the screen. And then this one, it's quite snug. Yeah. That was a little bit bad that I started to print like that. Only a hair to like a 16th of a turn on this wheel in the back is what it needed. So now we come back down. Next, it's finished. Now everything's got to heat up again. Finish. Calibration Z-axis. No, I'll do that next time. I'm gonna do print. 3D benching. Print. Yeah, now we're down to 83 and 135. Okay, temperature's almost fully up. I don't see oozing, so that's neat. I mean, I could look from above, but like up there, but you wouldn't get a better view. So this is just gonna not be in focus until maybe later. I'm not gonna hold the tripod like this either. Okay, get ready for a result later. So this one was made yesterday, and now I'm testing the left extruder, making the same part. I'm going to adjust some settings, and then finally I'll test both at the same time. Holy cow, it's really happening. 2 prints on 1 printer simultaneously. Man, that's neat. What are we gonna make? We're gonna make these. It's like 2 printers.